Yeah, so hello everyone, welcome to OneClass YouTube channel. My name is Devansh and today we are going to go through a couple of popular Q&A mathematics questions and a little background about myself. So I am an undergraduate student. I'm in the final year of my program in Bachelor's of Technology in Aerospace Engineering. So if you want any homework help or if you want any tutoring help, then you can check the links in the description below and do hit the like bell and subscribe button, and also so that you will be notified for another live session. So let's start with the so let us start with the first question. So the first question we have what is the surface area and how it is computed? So this is a kind of general question, the surface area and its computation. A three-dimensional shape is a solid shape with height and depth. Examples are cube, sphere, and others shown in the image below. So we have a cube, then cuboid, then square base pyramid, cone, then this is triangular prism, then triangular base pyramid, then cylinder, and a sphere. Now, the surface area of all three-dimensional shape is the sum of the surface area of all of its sides. There are two types of 3D shapes to deal with here, prisms and non-prisms. So we have non-prisms, lateral and curved K. So first I will start with a normal thing. So surface area. Yeah, so surface area is basically term for 3D shapes. For 2D shapes, we just use the term area, but for 3D shapes, we have volume. So for if we want, if we just want the surface area of the sides, then suppose if this is a cube, then let's say this is a cube, not a pretty one, but let's say this is a cube. Okay, so a cube is a 3D figure 3D figure. Then we take volume for cube. Let's say the side of the cube is S. So the volume will be S into S into S. It will be S cube. Now, when we go for area of a square, square area, then it was side into side. And cube also has a couple of squares, or the faces are in square shape. So a cube has 6 faces. This is 1, 2, then this is 3. Then on the back side we have 4. Then here on the back side 5, and on the bottom we have 6. So cube has total total of 6 faces, and area of each like every face is a square. So area of 6 faces uh, faces will be 6 into area of one face will be a square. So the total surface area is 6 times a square for a cube. Now let's go to the prism ones. A prism is a 3D shape with non-curved surfaces and a pair of congruent sides called bases. It includes the cube, triangular prism, and rectangular prism, among others. There are two ways to compute the surface area of a prism. Option A, find the perimeter of the base and multiply by height. For example, the formula for the surface area of a prism is given below. We take the perimeter of base and then we multiply it with the height plus area of bases, where p base is perimeter of base and h is height of and h is the height, and a basis is the area of the bases. Option 2 is add the area of the sides together to find the total area. So suppose if we have an equilateral prism, and say we have one more dimension in this side, and this is a square base pyramid. Now let's say the surface area of base will be surface area, let's say the a a and a, and as it is an equilateral triangle, so the sides will also be a. So surface area of base will be a into a, because surface area is a square and the area of square is a square. So a base will be a square. Now for sides, we have is the length, this is the slant height of this prism or the pyramid. So the slant height, we can also find the area of an equilateral triangle. So let me just confirm the area of equilateral triangle. Equilateral triangle. So area of an equilateral triangle is root 3 by 4 into a square. Now we have four sides, so we'll just multiply this because we have four triangles, four equilateral triangles. So we'll just multiply this by 4, and then the total surface area of a equilateral square pyramid will be equal to area of base plus area of 4 triangles. So this will be a square plus 4 times root 3 by 4 a square. 4 and 4 can get cancelled, and we have a square 1 plus root 3. In this similar fashion, do we have the area? Right pyramid, we have the surface area of right prism. Right prism is not given. Let's do for one more thing. Let's find for cylinder. So for a cylinder, we have one cylinder. Here we have a circular base and two circular faces, and this is the curved area of the cylinder. So let's say the height of this is the height of the cylinder, and this is the radius of the cylinder. Now first we have one square, one circle, one more circle, so we have two circles. So for total surface area we have two circles plus one curved part. Now first I'll start with circle. The area of circle is pi r square. Now if we see, if I just open this cylinder, I will get a figure like this. This part will be h, this will be radius, this will be radius. So when I open a cylinder, the curved surface will look like a rectangle. The height of the rectangle is the height of the cylinder, but for the length of the cylinder, length will be equal to the circumference of circle. So as you can see, we have this. So the length will be basically, if I cut from here, then length is the circumference or perimeter of the circle. So perimeter of the circle is 2 pi r. So I get the length, then height is height, then my area of rectangle is L into h, then it will be 2 pi r into h, which will be 2 pi r h. Now total surface area of cylinder is area of all the faces. It was 2 times area of circle, which was pi r square, plus area of the curved part, which is 2 pi r h. We can take 2 pi r common, r plus h. So this is the formula for area of a, so you can see this is the formula for total surface area for is basically 2 pi r plus h. Here also we got the same formula. Here we have one more formula, which is the lateral or curved surface area. So in the case of a lateral or curved surface area, we do not include the base of the figure, neither base nor the top part. So for suppose for cube, the total surface area was 6s square, where s was the side. For lateral surface area will not include the top face, include two faces from 6 faces, then my lateral surface area will be 4s square, because it will include this 1, 2, the back one and this side one, only 4 faces. In prism also we do not include the base, or in the pyramid we do not include the base. So the lateral surface area for a pyramid will be just root 3 into a square. And same for cylindrical, for curved surfaces, we just take the surface area of the curved part. So for cylinder, we can get curved surface area is nothing but 2 pi r h, the area of the rectangle which was curved. So here also 2 pi r h, we get non-prism. To compute the surface area of sphere, cylindrical, pyramid and other non-prism, use the specific formula as shown in the table. So these are the formulas for sphere. For sphere we have 4 pi r square and then again 4 pi r square, because for sphere each and every part is the curved surface area, or for a sphere, like whole sphere is a curved part only, so we do not have any base or top part in a sphere. That's why the curved surface area and total surface area for sphere is 4 pi r square. For hemisphere we have a base also, a flat portion. Suppose this is a semicircle. uh, Imagine this as a 3D shape. I'll just draw this. So for hemisphere, uh, yeah, for hemisphere we have this half sphere part and we have this base part. So in this case, the curved surface area will be equal to half of total surface area of a sphere. We can just cancel this and we'll get 2 pi r square. But for total surface area, we have this curve part, but we also have a base part, this part. So, and the radius of this base is again r. So, in the curved surface area only, we'll add area of one more circle to get the total surface area. And here, total surface area of a sphere will be 3 pi r square. The surface area 3 is the sum of surface area of all its sides for prism in the multiply. This was the correct solution. Good job. Solution is where is my mouse? Yeah. Then we add one more page. Question number 2. What are same side exterior angles? So same side exterior angles, we have same side exterior angles are ones of the angles formed when two parallel lines are cut by a third intersecting line called a transversal line. The same side exterior angles are called this way because they are angled on the same side of the transversal line and are on the outer side of the parallel lines. Okay, for straight line I'll just use a red color for this. This is one straight line, then this one is another straight line, then this, say now this is the transversal line. These are the two parallel lines. Let's say this is one angle, this is another angle, A and C. So these angles A and C, these angles are called as A and angle C are same side exterior angles, and there is one more thing, that angle A is equal to angle C also. There is a property for parallel lines. So for example, um, like there is one more property. So there is one property that if there is if there are two parallel lines, and if one straight line cuts those two parallel lines at certain points, then the same exterior angles, which is angle A and C, will be equal in magnitude. We can also prove this by, let's say, just the total sum of this angle and this angle is 180-degree, and we have this alternate uh, uh, what was the property? It was alternate interior angles was this one will be equal to this one. So I will just skip. I think, let me just cross check the property. It was sum of alternate same, what is same side exterior angles. Okay, I did a mistake. These are not equal because it will void the um, alternate interior angle property. Sum of angle C and sum of angle A is equal to 180-degree. These are complementary angles. So angle A plus angle C will be equal to 180-degree. This way, because they are called external transversal line, the angle C and A and C are same side exterior angles, since they are both on the same side of the transversal line and are on the exterior outer sides of the parallel line. So this was also correct solution. Great job. Let us go to question number 3. So how do we simplify e power ln of x? So we have a property, say this thing is very easy, like we have a property e power, suppose if we have a log, so a log of base a times log of x with base a will be equal to x. So if the base of the log and the number at which the number uh, towards the number at which we have raised the power, So basically, like if we have a number and on the power of that number we have a log and the base of that log is equal to this number, then this log vanishes and we get only x. So in our question we have e power ln of x, which is natural log, so I can write e power log of base e of x will be equal to x. This was pretty easy. E power using the property of log. Yep, so e power ln of a. Question is correct. So correct solution, great job. Solution is correct. We will go to the question number 4. Question number 4. Find the derivative of y equal to tangent of x plus cotangent of x. So y equal to tangent of x plus cotangent of x. So derivative of tangent of x is secant square of x. Cotangent of x is minus of cosecant square of x. So dy by dx equals to secant square x minus cosecant square x. Do we need to simplify this? Okay. So here they have separated like sine and cosine, then they have simplified it. Okay. So this will be basically secant square x and cosecant square x will be 1 over cosine square x minus 1 over sine square x. When we take the LCM, we get sine square x minus cosine square x. So cosine square x into sine square x. Now, let us divide with 1 by 1. I divide it with 1 by 1. Nope, nothing will happen. Let me multiply and divide. Okay, not this step. I'll just multiply and divide it with let us go with this solution first. So dy by dx is derivative of sine x cosine x plus cosine x over sine x. I will just use the quotient rule. So first sine x will be differentiated, so cosine of x, then sine will be cosine of x, then minus, then cosine of x will be differentiated. It will be minus sign, so minus minus plus, sine of x into sine of x over cosine square of x plus cosine x is minus sine x times sine x minus derivative sign is cosine, and cosine is taken as cosine only, and we have sine square x. Now this will become cosine square x plus sine square x, and cosine square x plus sine square x is 1 over cosine square x minus, oh god, I'm getting the same solution, sine square x plus cosine square x over sine square x. Again this will be 1, so 1 over cosine square x is basically it was secant square x minus cosecant square x, the same solution which I got here. It can be further simplified, so let's see how they have simplified this. Applying the product rule, they have written cotangent of cosecant of x, sine of x, cosine of x and sine of x. Okay, sine x derivative of cosine x, cosine x derivative of sine x. Let's just manipulate the answer. So I have cotangent will be cosine over sine square minus 1 over cosine if I take the LCM. This solution is not looking correct. If I take the LCM, then cosine square minus sine square over sine square cosine, and in my case when I took the LCM, it will be sine square minus cosine square minus cosine square over sine square cosine square. Okay, so the solution given here is incorrect because this cotangent and cosecant will be cosine square and minus sine square over sine square times cosine. If I multiply cosine, then also I'm not going to get the same solution. Solution is incorrect. Correct solution is secant square square x minus cosecant square x, or 1 over cosine square over cosine square x minus 1 over sine square x, sine square x. Solution is incorrect. Correct solution is secant square x minus cosecant square x, or 1 over cosine square x minus 1 over sine square x. Now this was 1, 2, 3, 4. Question number 5. Question number 5. How do we integrate 1 over s square plus 1 ds? So 1 over s square plus 1, the given integral is actually the inverse of tangent function. Okay. So, okay. So let us say my s is tangent of theta, then ds will be secant square theta d theta. So let us substitute back s in this equation. So 1 over tangent square theta plus 1 times ds is secant square theta d theta. ds is secant square theta d theta. So 1 over tangent square theta plus 1 will be equal to 1 over secant square theta, because tangent square theta plus 1 is secant square theta, multiply secant square theta and integrate with d theta. Secant square will cancel, and integration of 1 d theta will be equal to just theta. Now tangent of theta was s, then theta will be equal to tangent inverse of s. Here we'll have plus c because this is an indefinite integration. So integral of 1 over s square plus 1 ds will be equal to theta plus c, which is tangent inverse of s plus c. Tangent inverse of s plus c. Okay, so correct solution. Solution is correct. This was question number 5. We'll go to question number 6. How do you use the fundamental trigonometric identities to determine the simplified form of the expression? So let me see. Okay, so we have fundamental. First we'll go for fundamental trigonometric identities. So sine of x equals to 1 over cosecant of x, then cosine of x is 1 over secant of x, then we have tangent of x equals to 1 over cotangent of x, then we have tangent of x is sine of x over cosine of x, cotangent of x is cosine of x over sine of x. Then what all identities we have here? We have some more identities. So sine square x plus cosine square x is 1. 1 plus tangent square x is secant square x. 1 plus cotangent square x is cosecant square x. Now the example given here is simplify cotangent of x and sine of x. So I will write cotangent as cosine of x over sine of x, then sine of x. So this will be simplified, and I can we can take one more question. Let's say tangent of theta times sine of theta plus sine square of theta, not sine square. Let us say cotangent of theta times cos of theta. So sine tangent will be sine theta over cosine theta, sine theta plus cosine theta over sine theta, times cosine theta. Well, okay, so this can become sine square over cosine theta plus cosine square theta over sine theta. I can take the LCM also, so this will become sine theta sine square theta plus cosine theta cosine square theta over sine theta cosine theta. Then this will be sine cube theta plus cosine cube theta over sine. This can be an endless question. I'll just take one more. Tangent of theta plus cotangent of theta. So tangent is sine theta over cosine theta plus cosine theta over sine theta. We'll take the LCM, so sine squared theta plus cosine squared theta over cosine theta sine theta. Then sine square plus cosine square will be 1. This will be 1 over using this identity, and then again we have cosine theta sine theta. I can also write this as 1 over cosine theta times 1 over sine theta, which can also become like 1 over cosine theta is secant theta times cosecant CSC theta. So in this way we can use the basic trigonometric identities for simplification of the equations, trigonometric equations. So correct solution, good job. Solution is correct. This was question number 6. Now question number What is reflexive property of an equality? Okay, this is a very basic. I think this is like a junior school level question. Like everyone knows this. The reflexive property of equality states that a number is equal to itself. If A is a number, then A is equals to itself. So let's say A is equals to A cannot be not equal to A. Negative A is not equal to A because we have one negative sign here. Then example x equals to x, 2 by 5 equal to 2 by 5. Then let's say tangent of theta equal to tangent of theta. Then say under root of 2 into 2 equal to under root of 2 into 2. Then 5 square equal to 5 square. So basically a number will always be equal to itself, doesn't matter whatever happens. Oh. Solution, great job. Solution is correct. We'll go to the next question, question number 8. So for this we need to find the antiderivative derivative of secant square x. So basically we need to find integral of secant square x dx. So we can have a lot of like approaches. I will go with the direct formula. So derivative of d dx of tangent of x is basically secant square of x. So antiderivative of secant square of x will be equal to tangent of x. But we have a c here because this is an indefinite integral, so a constant will be added. Correct solution. Nice work. Solution is correct. Question number 9. Okay. So we need to simplify oh god, this one note. Simply seriously one note. 1 minus sine square x. Now we'll just use the property sine square x plus cosine square x equals to 1. So if I I subtract cosine square from both the sides, then sine square x will be equal to 1 minus cosine square x. Now I substitute the value of cosine square back into the question. So 1 minus sine square x. So 1 minus cosine square of x. This will be 1 minus 1 is 0. Negative negative will become positive, and this will be cosine of x. That will be only cosine of x. Okay, so cosine of x, correct solution. Good job. Solution is correct. We'll go to next page and yeah. So question number 10. Find the derivative. Okay. d dx of tangent of x plus cotangent of x. I think I have done this question before. Derivative of tangent of x plus cotangent of x. Okay, so derivative of again tangent of x plus cotangent of x is secant square x minus cosecant square x. We have the whole derivation kind of thing here. This secant square x minus cosecant square x is inverse of cosine square x minus inverse of sine square x. Now given, let's see the final solution. Let us go through this solution. So derivative of tangent and cotangent, we'll use the sum rule for differentiation. Then we take the derivative of tangent of x, and we take the derivative of cotangent of x. So tangent of x is secant square x, and cotangent of x is negative of cosecant square of x. So we have y equals to tangent x plus cotangent x is derivative is secant square x minus cosecant square. This OneNote is really bothering me today. Hello, OneNote, work, please work. Yeah, so secant square x minus cosecant square x. So the solution is, I'll just write the direct answer. dy by dx is secant square x minus cosecant square x. Correct solution. Okay, we have one more question. Question number 11. We need to simplify tangent of pi plus theta. So here they have used the formula. So formula of tangent of alpha plus beta will be equal to tangent of alpha plus tangent of beta over 1 minus tangent of alpha times tangent of beta. So will tangent of pi plus theta will be equal to tangent of pi plus tangent of theta over 1 minus tangent of pi times tangent of theta. Now tangent of pi is sine pi over cosine of pi. Sine pi is 0 and cosine pi is -1, so tangent of pi is basically 0. So we put the value of tangent of pi in this equation. So we get tangent of tangent of pi plus theta will be equal to tangent of pi will be 0 plus tangent of theta over 1 minus 0 into tangent of theta equal to tangent of theta. Now, simplify, you can use also is the angle sum and difference identity for this with tangent of theta. Can correct solution. Great job. Solution is correct. Okay, so that is all for this session. If you like this session, then please hit the bell icon and do mention in the comments also, and hit the like button also. And to for staying updated and to get for our next videos, you can also subscribe. And if you need any tutoring help, one-to-one class sessions, or if you want to submit your own questions, or if you need any homework help, then you can check out the links in the description below. This was Devansh, a senior tutor at OneClass, and I will see you in the next video. So